Okay, so if, yes,
I had problems submitting the video last night.
yeah, I think everybody did. I was assuming that we could put multiple files in that thing. We cannot. But what we'll have everybody do is just everybody email me your presentation, and then you can just pull it up off of this computer. Then you won't have to worry about it. And we would prefer this. This system used to be able to plug into different computers. You bring up your own laptop, but the whole system died last year, and now my computer is just directly connected to the projector, so it's easier to just use it that way. They're going to fix it eventually. You might even see it fixed sometime during this semester, but for now, that's what's going on. Okay, so I'm going to give you a few minutes to email me your presentations. I will be right back, and then we'll start.
What I tried to do is have pictures, but not a lot of words.
What I tried to do was like, I had a few words.
Okay. You guys ready for this?
Bring it up.
Now, whenever we do presentations in this class, which we do a few times, about a third of your grade, 35 points out of 100 of them, will be based on your actual presentation that you give. The other 65 points would be partially participation. You're here, you did it, you came, you saw, you conquered. And another 35 points of it will be your evaluation of other students in the class. So each of you will be required to fill out a form like this for 2 other students in the class, your choice. But included with this form is you must come up with at least 2 questions to ask. It can either be 1 question from each of the people that you evaluate, or it can be 2 questions from 1 person that you evaluate. Depends on what you say. And when you ask that question and they give their answer, I want you to take notes on the back of this sheet. Does that make sense? So you're going to start by putting your name on the top and then the name of the presenter that you're going to evaluate. You don't know who that is yet, maybe, but that's fine. And then their topic, and then every one of these things has a couple of questions. There's 7 or 5 of these things. And you have this scale from 1 to 7, 4 to outstanding. And there's a little bit of room for making some notes. I would like you to give a little bit of feedback, constructive feedback. Don't just say, it stunk, right? Put on there, maybe you could have used more pictures, or I would have enjoyed to see more eye contact with the audience, or whatever, right? Constructive criticism. I want some of that on each one of these for every student, for each of the students that you do. So you're going to give them a score, which I usually do at the end of the talk, or somewhere near the end. And then some feedback, and then you need to ask 2 questions. It can be 1 each person that you evaluate, or 2 questions to 1 person to evaluate. And then take notes on the ensuing conversation. Does that make sense? All right? I, of course, will do an evaluation of each of you, so your 35 points based on your presentation will come from me. The evaluations you do of each other will not affect each other's grades at all, but I want to make sure that you're giving each one of these a score and a reason for it. I want to know what you thought of your fellow students' scores. Those will not be shared with the other students, nor will they affect the other students' grade. Okay. Sorry, did somebody have a question? No? Yeah? No? Okay. So here is the rub. Who wants to go first? Does anybody want to go first? Oh, we have a volunteer. You can go second. He raised his hand first. So, all right, come on up here. Let's get you all set up. If you would like a lady somewhere. Needs batteries, it feels like. I have another one here somewhere too. I have lasers all over this room. Let's put a battery in this one. Make it work. Maybe we will, maybe we won't.
When I was making my final touches, I thought about having a laser pointer because I assumed you might have one, but just in case, I made sure
Didn't have to
I
have
didn't
one.
need to have
Well, I think that this one will be operating here in just one quick hurry. No, maybe not. I'll try. I'll work on that later. So I don't think this thing has a laser built into it. It doesn't. But oh, I have a blue one here. Can't really see it on the screen. Just don't have a bright. Oh, here's a bright green one. There we go. No, where is it? Not showing. Not working. Never mind. Okay, I'll work on getting those working. But PowerPoint.
I just emailed it to you. And
Okay.
It says saved as a PDF.
Okay. So wherever it is here in your, so maybe that's it right there.
Yeah.
So you can go ahead and just open it from there, and you're good to go. So we're giving each of you about 10 minutes-ish. I think you said 8 minutes or 7 minutes or something like that. Go ahead.
It's like 7 minutes.
7 minutes, all right. Just a little pointer, if you're using a PDF, go ahead and push that green button up on the left side there. And that will take you to full screen. There you go. Go ahead.
Nuclear engineering is a relatively new form of engineering that has been around since around the mid-1930s. The history of it can be started with many physicists. The first ever considered nuclear engineers could be Fritz Strassmann and Otto Hahn. These were German physicists that are credited with the first relative forced fission of a uranium atom. Because of Germany's possible capability of uranium fission, this led to Albert Einstein writing a letter to Franklin Delano Roosevelt. This is what led to the Manhattan Project. The Manhattan Project led to much of what we do know now about atomic theory. This project was headed by J. Robert Oppenheimer. Even though uranium and plutonium fission is not one of the best ways for power generation, much of the science we have today is based on their original designs. What do nuclear engineers do? Most people think of nuclear power plants, nuclear laboratories such as the Oak Ridge National Laboratory, but there's much more than that. There's much applications of nuclear engineering within medicine, as well as atomic theory, such as CERN. Many people think that these nuclear engineers will oftentimes work with nuclear reactors, but that is not entirely true. They can work with certain isotope creations, as well as medical applications of radioisotopes. Nuclear power plants are oftentimes run by bachelor degree nuclear engineers, with them often looking after the reactors themselves. The typical education for an entry-level nuclear engineer is a bachelor's degree, but this can go up to a doctorate, especially with much more specialized and necessary requirements for a more advanced part of this field. Oftentimes, they can require a license due to the radioactive nature of the materials they work with. Many government organizations, such as the Nuclear Regulatory Commission, as well as the United States Department of Nuclear Energy, regulate this extremely due to the possible extreme danger that is within their field. Even though a bachelor's degree is the common entry level, it is common for a master's degree in nuclear engineering to lead to more higher reactor management within the United States. There is a high future of nuclear engineering. Even though it's projected that the job outlook is only around 4% by 2026, it is estimated to increase after that. A big reason it's so small is power generation jobs are decreasing, especially with the shutdown of new nuclear reactors. At the current time in the United States, there is only one modern nuclear reactor in production, and that is in the state of Georgia. This is mainly due to a fear of nuclear power plants from many such occasions as Fukushima, Chernobyl, and 3 Mile Island. Even though these possibilities are dangerous, people have shown that nuclear engineering is an increasing field for the future. The Department of Energy has been investing millions of dollars in modular reactors. These modular reactors, so-called plug-and-go reactors, could be brought to disaster areas and almost instantly start producing power in a clean and efficient way. Because of these increases, many people think these modular reactors will increase the amount of jobs within power generation. Even though power generation jobs for nuclear engineering are decreasing, many jobs within the medical field are increasing due to new radiotherapies used within the medical field. Another possibility for nuclear engineering would be within national laboratories. Without nuclear engineering possibilities, places such as the Oak Ridge National Laboratory could not create isotopes necessary for the creation of new elements. A prime example would be such as element 118, oganesson. This was developed by different isotopes developed at the Oak Ridge National Laboratory that was developed through nuclear engineering, even though the chemists developed the isotopes. Other future possibilities within the field could be nuclear use in space programs. It is theorized that nuclear-powered rockets could be an extremely efficient way to provide efficient propulsion to places such as Mars. And because of this, it is believed that a nuclear future in space is very possible, with nuclear being used in space technology since the 1950s, such as radioisotope thermoelectric generators that power things such as the Voyager programs. Because of this, nuclear engineering within space programs has been relatively low, but could increase with further generations. The so-called Dragonfly project for the Saturn's moon Titan could be a nuclear-powered drone to fly across the moon. A final look at nuclear engineering goes to a very broad area. I thought that would be less word. Nuclear engineering is considered one of the most clean and efficient forms of power, with its density of nuclear fuel being able to be used to generate relatively low carbon energy. This, even though it has a decreasing rate, can show to be a clean form of power. Many people believe such as Chernobyl accidents can be a good example of why we shouldn't use nuclear power. However, new designs of nuclear reactors by nuclear engineers have shown that the possibilities of meltdowns are near 0%. Because of this and their high efficiency, it is believed that nuclear power could be our key to clean, efficient power generation within the future. Another form of power generation by nuclear would be within the next 50 plus years, possibilities of nuclear fusion technology. Nuclear fusion doesn't produce radioactive waste like normal nuclear fission forms, but it's an extremely hard form of science that they've been saying is 15 years away since the 1940s. Power generation isn't the only use of nuclear engineering, with nuclear medicine being an extremely increasing field with cancer treatments as well as other non-invasive forms of determining ailments being used through nuclear science. An example would be actinium-2, it would be a special isotope of actinium that is produced at the Oak Ridge National Laboratory from thorium. This, even though its extreme price, can show that maybe only a couple thousand atoms could be used in an extremely high dose to eliminate cancer cells. Because of this, nuclear engineering, even though right now may show a relative decrease in their field, the far future could show a long increase within it. Thank you.
Excellent, thank you very much. Do we have any questions?
Is there a reason that you chose nuclear energy power?
Ever since I first learned about nuclear power being one of the more clean and efficient forms of power and how many people fear it due to their lack of understanding, I've been a relatively high proponent of nuclear power, especially since its high energy density and the possibility of recycling nuclear waste being an extremely good way to end our extremely high carbon emissions for power generation.
What kind of diseases or is it cancer that you're trying to cure with nuclear medicine? Or
Most of the research I found is extremely high doses of not specialized, but extremely concentrated areas of radiation can kill those cancer cells really effectively, and it has shown more promise with the more exact we can subject those tumors to radiation. From what I saw, there is more possibilities, but I don't know that much. I'm not very good at biology when it comes down to it.
Just as a point, technical reference, it is mostly cancer. Because the only way to cure cancer is to kill it, and radiation kills. So yeah, it's also, it's not poison, which is nice because when you use chemotherapy uses a poison to kill the cancer. And unfortunately that poison kills everything in the body as well. Right? So if you can focus your radiation, you'll see the point, or it's in somebody they radiate differently. Sometimes they actually irradiate it with focused radiation. Sometimes they actually put a little piece of radioactive material right inside the cancer cell, or right inside the cancer's tumor. But either way, if you can concentrate it on space, then you can reduce the amount of damage done to the rest of the body.
I follow a lot of nuclear proponents, like the Department of Nuclear Energy, and there was something I read that they released. They're working on biodegradable nanobots with actinium in it, and those are specialized to go to the cancer cells.
So they don't have to do surgery.
Yeah.
Yeah. Now, there's lots of interesting things going on with I'm going to give you a little piece of immediate criticism, just because if you want to go into nuclear science, you have to pronounce nuclear. If you pronounce a nuclear, then they will hammer you from day one, and you don't want to be hammered in that field from day one. But thank you very much. Let's give you one more round of applause. Okay. Let's go ahead and have our second victim. Are you ready?
No. I need like 5 more minutes.
Okay, so
I'm changing some stuff.
somebody else want to go?
I think I put too much stuff on this side.
Did you get my,
That should be my email.
yes.
If nobody volunteers next, then I have to just volunteer somebody at random. So. Let's see.
I'll go out.
All right.
Which one is yours?
Some from my iPhone.
This is yours.
That's probably it, yeah. I hope it'll have the same font
It
as,
should. PowerPoint's pretty good at that these days. Did it work out?
yeah, it should have. Hang on, is there a play button in here?
Yeah, if you go down to the bottom right, the little screen on the bottom right. Oh, sorry, bottom. Is that? No, bottom. Yeah, that's it right there. Hit the little screen. No, that's not it. What am I thinking?
What is
It's over here. I'm looking at that. Right there, that little screen.
There's no little screen there.
This one right there.
Oh, that one. Oh,
That's your